Last year, I told you I was going to buy the Nvidia DGX Spark, and a lot of you agreed with me. Some of you, however, very much did not, and the comments were lively. I read all of them. And now, Nvidia went and announced a second Spark. Same name, almost, the RTX Spark. And here's the thing that made me actually sit up. It quietly fixes the one complaint I kept hammering on in the last video. But, and you know there was but, the spec sheet is hiding a very familiar problem, and we don't even have a price. So today we're going to look at what the RTX Spark actually is, who's it for, and for me specifically, whether it fits the way I actually want to use a machine like this. And I'll be upfront, I'm looking at this through a very particular lens. I want to run local LLMs, I don't want to have a laptop but a desktop kind of thing, and I want it running Linux. So as we go, that's the question I keep coming back to. Does this thing work for someone like me? Okay, let's get into it. First, let's clear up the confusion, because Nvidia did not make this easy. We now have two Sparks, and they are not the same machine. The DGX Spark, the one from last time, is a Linux box. It runs a special Ubuntu-based distribution. It lives in the CUDA and Nvidia data center world. And it's really aimed at developers and researchers who want their desk machine to look exactly like the cloud they deploy to. The RTX Spark is the consumer version. Same chip family, the GB10 Grace Blackwell silicon, co-designed with MediaTek, but this time it's running Windows, on ARM that is. Same hard, completely different target buyer. Keep that distinction in your head, because almost everything that's interesting about the RTX Spark comes from one decision. Nvidia took the dev appliance and turned it into a Windows machine. So let's put them side by side and see what's actually different. The CPU is the same idea. A 20-core Grace ARM chip, 10 performance cores, 10 efficiency cores. The GPU is a Blackwell 6144 CUDA cores with 5th gen Tensor cores. And FP4 support, of course. Both can be configured with up to 128 GB of unified LPDDR5X memory. So far, they pretty much look like twins. Now, the two rows that actually matter. First, memory bandwidth. The DGX Spark runs at 273 GB per second. The RTX Spark is rated a little higher, up around 300. We'll come back to whether that bump means anything. And spoiler, not much. But on paper, it's slightly better, not worse. So yeah, fine. Maybe it's just marketing speak for 273 GB. Who knows? Second, and this is the one, networking. The RTX Spark, it drops it. No ConnectX, you get Wi-Fi 7, 10 GB Ethernet instead, and honestly, for the vast majority of people who just want one box on their desktop to run models, that is the right call. Nvidia finally gave us the version without the expensive networking card I was never going to plug into a second unit, and on my guess, most of you neither. The rest, the DGX runs DGX OS Linux. The RTX runs Windows 11 on ARM. Power on the chip drops into the 45 to 80 watt range instead of around 140. But I'm not sure if they are only referring to the laptops and not the mini PCs. This will be an interesting thing to keep an eye on. And the price? Well, the DGX Spark is now $4,699 for the 4TB version, after its little price hike due to the insane memory prices right now. The RTX Spark price is officially to be announced. Well, hold that thought, because it matters a lot. Okay, let's talk about bandwidth numbers, because this is the part the marketing slides don't really want you to focus on. If you watched the last video, you know my whole thing. For running large language models, the single most important number for inference is memory bandwidth. No tops, no core counts, bandwidth. When the model is generating tokens, it has to stream the entire model through memory for every single token. So your ceiling is basically how fast you can move data and not how fast you can do math. So when Nvidia tells you the RTX Spark goes from 273 to about 300 gigabytes per second, yes, that's an improvement, no doubt. It's also about 10%, but that's not a kind of jump that changes your life. And look at where that sits. A single RTX 3090, a card from like years ago, does 936 gigabyte per second. An M5 Max does over 600. The RTX Spark at 300-ish is down here with the DGX Spark and the Strix Halo machines. These unified memory boxes are not fast at generating tokens. What they give you is capacity. Enough memory to load a big model at all, not speed. That's the trade. It was the trade last time and it's a trade now. So if your dream was a tiny box that spits out tokens as fast as a dedicated GPU, I have to be brutally honest with you and tell you this one. This is not the machine. Now, the last video, a lot of you pointed out something I glossed over. And the top comment basically called on me, and in a nicest way. So let me fix that, because it's exactly where the Spark machine actually have an advantage. When you talk about LLM speed, there are really two different jobs happening. The first is prefill. That's the model reading your prompt and your context, chewing through everything you send it before it answers. This part is compute bound. It leans on raw math on those FP4 tensor cores, when you use the right models, that is, of course. The second is decode, actual writing the response, token by token. That's the bandwidth bound part we just talked about. Here's why this matters. Last time I focused almost entirely on the decode, tokens per second of output. But if you're doing long context work, feeding in big documents, working on a reasonable sized code base, doing RAG, running agent workflows that stuff huge prompts in, prefill is where you spend your time. And this is where the Blackwell Spark generally pull ahead on an Apple machine or a Strix Halo box. The DGX Spark's prefill on big model is several times faster than the AMD equivalent. The RTX Spark, same silicon, should do the same. If this matters to you, really depends on your workloads, something only you can decide. So the honest, complete picture is this. These machines are modest at writing tokens, but strong at reading them. If your workload is long prompts and short answers, that changes the math in the Spark's favor. If it's short prompts and long answers, it basically doesn't. Knowing which one are you tells you most of what you need to know. And thank you for everyone who pushed me on that. You were right. There's one more piece that is crucial when thinking about the Spark family of hardware, and it generally shifted how I think about these boxes. I want to give it a proper airtime. Mixture of expert models, MOEs. Here's the short version, and I'm not going to pretend to be the world's expert here. A traditional dense model uses every single one of its parameters for every token. A mixture of experts model is split into many smaller experts, and for any given token, it only activates a few of them. So a model can be enormous in its total size, which is why you need all that memory, but only a fraction of it's actually doing the work at any moment. And that is perfect for these machines. Think about it. The thing they have plenty of is memory, 128 gigabytes to be exact. The thing they are short on is bandwidth. A big MOE model fits in that memory, but because only a few experts fire per token, you don't have to stream the whole thing every time. You get to run the model that looks huge on paper at a speed that's actually usable. Something like GPT-OS 120B or Qwen3 MOE models, these are exactly the kind of thing a 128 gig Spark is built to run. So while I stand by everything I said about bandwidth, the rise of these MOE makes these high memory, modest bandwidth boxes a lot more interesting than the raw spec sheet suggests. So who should actually care about the RTX Spark? Because, like last time, this is not black and white, and it's not for everyone. If you live in Windows and you want one machine that has everything, runs your local model, plays your games, and has 128 gigs of unified memory to load like big LLM models, the RTX Spark is generally aimed at you. That's the pitch, and that's a real pitch. The DGX Spark could never be that machine because it's a Linux dev appliance. This one runs Windows on purpose. But let's be honest about the alternatives because you have them. If you specifically need CUDA, Linux, and fine-tuning, if your job is developing against the exact stack you'll deploy on the cloud, that's the DGX Sparks lane, not this one. Different tool. If you mostly care about value for local inference, a Strix Halo box like the Framework Desktop gives you the same 128 gigs and similar decode speed for most likely less money. Significantly less money, I guess. You give up CUDA and you fight with ROCm a bit, but your wallet will notice. And if you don't need the tiny footprint at all, if a model fits in 24 or like 48 gigs, two used 3090s will run circles around any of those on speed for less money while using a lot more power and space. That's the trade you get there. So the RTX Spark isn't competing with one thing. It's competing with all of these. And which one wins really depends entirely on your use case. Your actual use case, not the fantasy one. We've been there before. And here's where it gets personal for me, because this is the part that actually stops me. The RTX Spark ships with Windows on ARM, and I don't want Windows. I want Linux on desktop, running my local models, doing what I want it to do. Now, will it run Linux? Maybe. I mean, the DGX Spark, the sibling basically, runs Nvidia's own Ubuntu-based distribution, the DGX OS. Because it's the same GB10 silicon underneath, so it's reasonable to hope the RTX Spark could run it as well. But hope is doing a lot of work in that sentence. Nvidia hasn't said it will. This is a custom ARM platform with custom drivers sold as a Windows machine. And it's probably fine, is not something I'm willing to spend my money on. We simply don't know. And that uncertainty is a real problem for me. And then there's the thing I actually want to do with a box like this, run Proxmox. I like spinning up virtual machines to test things quickly. Different setups, throwaway environments, the whole point of having a capable dev machine on the desk. On a normal x86 box, that's a solved problem. On a custom ARM chip with proprietary drivers and a GPU that needs those drivers to be useful, I would not bet on Proxmox working cleanly, if at all. I mean, Proxmox doesn't officially support ARM, so you are in a limbo right at the bat. And then passing that Blackwell GPU through to a VM on this platform, honestly, I'd be surprised if that's smooth on day one. It's probably not happening. So from my use case, Linux, desktop, virtualization, local models, the RTX Spark has two big question marks hanging over it that the spec sheet doesn't really answer. And those question marks matter more to me than the bandwidth numbers do. Compare that to the Strix Halo box, which is a plain x86. I can put whatever Linux I want on it. I can run Proxmox, pass through what I need. It's a known quantity. The RTX Spark, for what I want, is not. Not yet, at least. So let me give you my take, like always. The RTX Spark might be generally the best Spark and what most people wanted. It drops a expensive NIC, it runs Windows, so it can be a real everyday machine. And it leans into exactly the kind of MOE models those boxes are good at. On paper, that's a better consumer product than the DGX Spark. I say that plainly. But here's the catch, and I'm not going to bury it. There are no independent benchmarks yet. This thing was just announced, and it doesn't ship until fall. We don't have a price, and given how Nvidia prices things lately, I would not assume it's cheap, and you probably won't get the 1 to 2K discount for the missing NIC. It's Windows on ARM with all its app compatibility questions that come with that. And for me specifically, the two things I'd actually need, proper Linux support and the ability to run something like Proxmox, are actually the thing nobody can confirm right now. Underneath the new badge, it's the same silicon with the same bandwidth ceiling we just spent this whole video talking about. For me, as it stands, it's an interesting machine. It fixes some real complaints, and it's still not the one I would buy on a limb. The Windows on ARM question and the Linux virtualization unknowns are deal breakers for me, how I work. And a plain x86 box gives me everything I actually need without the guessing game. If Nvidia confirms solid Linux support down the line, I'll happily revisit my opinion. Until then, it's a pass for me. And as always, figure out what you actually need before you spend a cent on any of these. Not that long ago, this whole category of tiny AI machines barely existed. And now we're spoiled for choices. That's a great problem to have. It also means there's no rush. So that's it. I hope you had fun and learned something along the way. If you did, thumbs up helps more than you think, and subscribe if you want more of those nonsense breakdowns. I don't post on a schedule, so that's your way of staying informed. Anyway, thanks, take care, and till next time, stay well.